This comes out of section 2.8, higher derivatives. So far to this point in this chapter, we've taken a lot of functions y equals f of x, and we've found their derivative. We've written that in a few different ways, y prime, or dy by dx, or f prime of x. But what we come up with when we take the derivative is just another function. So it makes sense that it must be possible to take the derivative of that. And it is. And so the notation can be, again, any of these type of notations, y prime prime. They have this funny d2y over dx squared kind of notation, or even f prime prime of x, which represents, the second derivative. And by that logic, you must be able to just keep doing it over and over and over, and that's what the title of this is called, higher derivatives. They even have other notations in case you run into them in other textbooks. Ours doesn't use this, but d2 of f of x, or d2 with a little x beside it, f of x. I wouldn't worry about those too much. We will stick to pretty much these three up here. And if we wanted a third derivative, we could call it 3 primes, or d3y over dx cubed, or f prime 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 of x, etc. So, third derivative, fourth derivative, etc. So, to do a very straightforward example, what if we started off with y equals 4x to the 7th, and somebody said, find the second derivative of that. So, the first job we have is to find the first derivative. To find the first derivative of this, we just use our regular power rule, say 28x to the 6th. The second derivative is just going to be the derivative of that. So d2y over dx squared is going to be 6 times 28, which is 168, x to the 5. And you could then, go further and further and further and take the third and the fourth and the fifth and the sixth derivative. What you'll notice, and I'll do an example of this next, is if somebody were to ask you, find the first 5 derivatives of a polynomial. So we're given this fourth degree polynomial, y equals 3x to the 4 plus 17x cubed minus 6x squared plus 11. We're asked to find the first 5 derivatives. Well, the first derivative, 12x cubed plus 51x squared minus 12x. Keep going, and the next derivative is 36x squared plus 102x minus 12. The next derivative is 72x plus 102. And the fifth derivative is 72. If we went further than that, every derivative after that, like the sixth derivative, 1, 2, 3, 4, 5, 6, and obviously the prime notation starts to be kind of ridiculous at this point. Every derivative after this, now that we have a constant, is going to be 0, 0, 0, 0. So 6, 7, 8, 9, 10th derivative of this particular function, a polynomial function, ends up being 0, because every time you differentiate these, their degree decreases by 1.